Hello everyone, my name is Sanket Kumbar and now we are presenting our second IC of electrical technology, that is on equivalent circuit referred to either side of transformer and the phasor diagram. And the group members are Pratik Sarvade, Sanket Kumbar, Tushar Kamble and Vinayak Kumbar. So equivalent circuit for transformer. Equivalent circuit diagram for transformer is basically a diagram which can be resolved into an equivalent circuit in which the resistance and leakage reactance of the transformer are imagined to be external to the winding. The equivalent circuit of transformer includes a setup of inductor, resistor, voltage, capacitor, etc. These circuits can be analyzed and experienced by applying the principles of the diagram theory. The simplified equivalent circuit of the transformer is drawn by representing all the parameters of the transformer either on the secondary side or the primary side, and the primary and secondary side equivalent circuit will be explained by the Pratik Sarvade.
Equivalent circuits refers to primary side. For drawing equivalent circuit of transformer refers to primary, first we have to establish the general equivalent circuit of transformer. Then we will modify it for referring from primary side. For a drawing this we need to recall the complete vector diagram. The voltage applied across winding is countered by primary induced EMF. Equivalent circuits refers to secondary side. Similarly, as transformer equivalent circuits refers to the primary, we can also reverse the primary parameters towards the secondary side by transferring the primary side to secondary side. If equivalent circuits parameters are refers to secondary, the primary parameters must be multiplied with transformation ratio. The simplified equivalent circuit will be explained by Tushar.
Okay, this is the simplified equivalent circuit of transformer. No load current is hardly 3 to 5% of full load rated current. The parallel branch consisting of resistance and reactance can be omitted without introducing any appreciable error in the behavior of the transformer under loaded condition. Further simplification of the equivalent circuit of the transformer can be done by neglecting the parallel branch consisting RO and XO. RO is resistance and XO is reactance. The simplified circuit diagram of the transformer is shown below. Next is phasor diagram of transformer. Phasor diagram of transformer on load condition. The phasor of vector diagram for a transformer or resistive, inductive and capacitive load are drawn by taking flux as reference. V1 is equal to primary supply voltage. E1 and E2 is equal to primary and secondary induced EMF. I1 is equal to primary current. I2 is equal to secondary current. IO is equal to balanced current or load component of primary current. When the transformer secondary is connected to resistive load, the load current will be in phase with the voltage. Next slide will be presented by Vinayak.
This is phasor diagram for inductive load. V1 is primary supply voltage, E1 and E2 primary and secondary induced EMF. I0 is no load primary input. I1 is primary current and I2 is secondary current. I0 dash is balancing current or load component of the primary current. When transformer secondary is connected to an inductive load, the current flowing lags with respect to voltage. This is phasor diagram for the capacitive load. V1 is primary supply voltage, E1 and E2 primary and secondary induced EMF. I0 is no load primary input. I1 is primary current, I2 is secondary current, and I0 dash is balancing current or load component of the primary current. When transformer secondary connected to capacitive load, the current flowing will be leads the respective voltage. Thank you.